Class 12, Chapter 1, Exercise 1.1, Question 11. Show that the relation R in the set A of points in a plane given by R, P, Q. Distance of the point P from the origin is same as the distance of the point Q from the origin. What does it mean? It means OP is equal to OQ. So, we have to prove that the distance of the point P from the origin, that is OP, is same as the distance of the point Q from the origin, that is OQ. So, these two distances are same. So, R is given like this and I have to prove that it is an equivalence relation. I have to show that it is an equivalence relation. So, let us do that. So, to prove equivalence relation, we need to show symmetric, reflexive and transitive. So, first show reflexive. Let P belongs to A. Then we know that the distance of P from the origin will be equal to the distance of P from the origin. OP is equal to OP. So, P belongs to R. For all P belongs to A. Hence, R is reflexive. Then for symmetric, we have let P, Q belongs to R. This implies OP is equal to OQ because P, Q belongs to R implies OP is equal to OQ. Now, if OP is equal to OQ, I can write it as OQ is equal to OP as well. So, it means Q, P belongs to R. Now, P, Q belongs to R implies Q, P belongs to R. What does it mean? R is symmetric. Now, for transitive, we have P, Q belongs to R and Q, S belongs to R. And I have to show that P, S belongs to R. Now, P, Q belongs to R means OP is equal to OQ. Q, S belongs to R means OQ is equal to OS. Now, OP is equal to OQ and OQ is equal to OS. What does it mean? OP is equal to OS. So, hence P, S belongs to R. If P, S belongs to R, what does it mean? R is transitive. Now, R is reflexive, symmetric, transitive. So, R is an equivalence relation. Now, next what they are saying, further show that the set of all the points related to a point P is the circle passing through P with origin as center. So, that is very obvious. Why? Set of all points related to P will have same distance from origin as P. Now, the points which are related to P will have same distance. This is origin, suppose this is P. Now, all these points are related to P if they have same distance from origin. So, all these points are related to P. All these are radii, right? All these are radii. So, they will form a circle. So, we will write it like this. Set of all points related to P will have same distance from origin as P. Hence, we can say that all points related to P forms the circle passing through P with origin as center. So, in written form, we can write it like this. To understand, we can have like all the points related to P will be all these points which are there on this circle, because all these points will have same distance from origin as P is having. So, all these are radii. So, if they are radii, so it means they are forming a circle. Now, next question is quite easy. Show that the relation R defined in the set A of all triangles are T1, T2. T1 is related to T2. Sorry, T1 is similar to T2. So, I have to prove that I have to show that it is an equivalence relation. So, let us show it. For equivalence, what we need to show? Reflexive, symmetric and transitive. So, for reflexive, let T1 belongs to A. Then I know that T1 is similar to T1. T1 and T1 obviously will be similar to each other. So, it means T1, T2 belongs to R because T1 and T1 are similar to each other. So, T1, T1 belongs to R for all T1 belongs to A. So, R is reflexive. Now, let T1, T2 belongs to R. So, what does it mean? T1 is similar to T2. Now, if T1 is similar to T2, I can write it as T2 is similar to T1. So, what does it mean? T2, T1 belongs to R. T1, T2 belongs to R implies T2, T1 belongs to R. So, what does it mean? R is symmetric. Now, similarly, we will prove for transitive. Let T1, T2 and T2, T3 belongs to R. Now, what I need to show? I need to show that T1, T3 belongs to R. So, it is also very easy. T1 is similar to T2 and T2 is similar to T3. So, it means T1 is similar to T3 also because T1 is similar to T2 and T2 is similar to T3. So, it means T1 is similar to T3. So, it means T1, T3 belongs to R. So, R is transitive. R is reflexive, symmetric and transitive. So, hence R is an equivalence relation. What else they are asking here? They are saying consider three right angle triangles, T1 with sides this, T2 with sides this and T3 with sides this. Which triangle among T1, T2, T3 are related? When they will be related? When they are similar. Now, you can see that these sides and these sides are proportional to each other. So, it means these will be similar. So, T1 and T3 are similar because T1 and T3 are having sides proportional. 3 to the 6, 4 to the 8, 5 to the 10. P2 is not similar to any of these, because if sides are proportional, sides are in the same ratio, then we say that the triangles are similar. So hence T1 is similar to T3 as their sides are proportional. Now question number 13, let us read that. Show that the relation R defined in the set A of all polygons as P1 comma P2, P1 and P2 have same number of sides is an equivalence relation. So let's do that. P1 and P2 have same number of sides. So we will first show reflexive. Let P1 belongs to A. Now P1 and P1 will have same number of sides because they are the same triangle. So P1 and P1 have same number of sides. So it means P1 comma P1 belongs to R. So it means R is reflexive. Now for symmetric, let P1 comma P2 belongs to R, and I have to show that P2 comma P1 belongs to R. So P1 comma P2 belongs to R, it means P1 and P2 have same number of sides. I can write it as P2 and P1 have same number of sides. So it means P2 comma P1 belongs to R. So R is symmetric. Now for transitive as well, P1 comma P2 and P2 comma P3 belongs to R. I have to show that P1 comma P3 belongs to R. Now P1 and P2, P1 comma P2 belongs to R means P1 and P2 have same number of sides. P2 comma P3 belongs to R means P2 and P3 have same number of sides. If P1 and P2 have same number of sides, suppose 3 and 3, then P2 and P3, 3 and 3. So it means P1 and P3 will also have same number of sides. So it means P1 comma P3 belongs to R. So R is transitive. Now R is reflexive, symmetric and transitive. So hence R is an equivalence relation. Now what else they are asking in the end? What is the set of all elements in A related to the right angle triangle T with sides 3, 4, 5. So this is very easy, as this is a triangle. So which type of polygon will have same number of sides as triangle? The set of all triangles will have the same number of sides as T. So the set of all elements in A related to the right angle triangle T with sides 3, 4, 5 is the set of all triangles, because all triangles will have 3 sides. So we can write it in this form, that this required set is the set of all triangles. Now question 14. Question 14 is, let L be the set of all lines in xy plane and R be the relation in L defined as R L1 comma L2. L1 is parallel to L2. Show that R is an equivalence relation. So we have to show here R is an equivalence relation. So here what I will do the same thing. I will consider L1 belongs to L, as here they have given the set L. R be the relation in L. So I will consider let L1 belongs to L. Now L1 belongs to L. What does it mean? L1 is parallel to L1. Now I can write as L1 is parallel to L1. Obviously, two lines are parallel to each other. The same line is parallel to itself. So L1 is parallel to L1. So it means L1 comma L1 belongs to R. If L1 comma L1 belongs to R, what does it mean? L1 is parallel to L1. So as L1 is parallel to L1, so L1 comma L1 belongs to R. So R is reflexive. Now I will consider L1 and L2 belongs to R, and I have to show L2 comma L1 belongs to R. So this is also easy. L1 and L1 is parallel to L2. I can write it as L2 is parallel to L1. So it means L2 comma L1 belongs to R. So R is symmetric. Now for transitive also we will write the same thing. L1 comma L2 and L2 comma L3 belongs to R. What does it mean? L1 is parallel to L2 and L2 is parallel to L3. So as L1 is parallel to L2, like this is L1 and this is L2. Now L2 is again parallel to L3. So it means L1 and L3 are also parallel. So what does it mean? R is transitive. So hence R is an equivalence relation because R is reflexive, symmetric and transitive. Now what they are asking in the end, they are saying find the set of all lines related to the line y is equal to 2x plus 4. It means I have to find the set of all the lines parallel to this line, parallel to the line y is equal to 2x plus 4. And we know that when the lines are parallel, only the constant term differs. So if you don't know, now you just learn the lines are parallel. If the coefficient of x and coefficient of y are same, only the constant term differs. So here we will consider the required set as y is equal to 2x plus c, where c will be different. C can be any constant. All those lines will be parallel to y is equal to 2x plus 4. Now we have last two questions of MCQ. Let R be the relation in the set 1, 2, 3, 4 given by R, 1, 2, 2, 2, 1, 1, 4, 4, 1, 3, 3, 3 and 3, 2. Choose the correct answer. So first of all, R is reflexive. Let us check R is reflexive. Yes, R is reflexive because 1, 1, 2, 2, 3, 3 and 4, 4 there. So here C option has gone because in the C option they are saying not reflexive. So it is reflexive. So just remove C option. If it is not, yes, so C option has gone. Now first option, R is reflexive and symmetric but not transitive. So let us check whether R is reflexive. We have already checked because 1, 1, 2, 2, 3, 3 and 4, 4 is there. Now symmetric, is it symmetric? No, it is not symmetric. Why? Because 1, 3 is there but 3, 1 is not there. Is it there? No. So it is not symmetric. So A option has also gone. As it is not symmetric, so D option also has gone because it is not symmetric. It cannot be equivalence relation. So what is left? B option is left. R is reflexive and transitive but not symmetric. Now 16. Let R be the relation in the set N given by R. A is equal to B minus 2 where B is greater than 6. So second is greater than 6. So A option, so we will cancel it first at the first place only because B is not greater than 6 here. So in these cases B is greater than 6 and the difference of these two is 2, right? A minus B is equal to, or B minus A is equal to 2. So A is B minus 2. A is 2, like A is 2 less than B. So the correct option is this. A is 2 less than B. If B is 8, A is, so correct option is C.